Okay, today our learning target is we will identify and create nets of three-dimensional solids. And also we're going to work on labeling the bases, faces, edges, and vertices of three-dimensional solids in both solid form and net form, which is a little bit more difficult. You kind of have to imagine your net being folded up into your solid. So we're going to start with this. Which shapes are needed to make a net of a pentagonal prism? This kind of puts together everything that we've been working on, both identifying plane figures or two-dimensional figures, having knowledge about how many sides they have, as long as how they're named, and whether we are going to be thinking about a prism or a pyramid, because that decides the other shapes of the figures. Now, we are just going to look for those shapes. We're not actually going to go ahead and draw the net. So really, we know that there are going to be two shapes that we need. And that first one that we're going to work on is the shape of the base, which is a pentagon, meaning a five-sided figure. Okay, again, I know that isn't perfect, but it's the best pentagon that I can do pretty quickly. It has 1, 2, 3, 4, 5 sides. Penta, yep, that's what we're looking for. And then we're going to look at this last part, prism or pyramid. Now, if this said pentagonal pyramid, then we would be drawing a triangle, because each one of those sides of the pentagon, if this were a pentagonal pyramid, would have a triangular face coming off of it that would meet at one vertex. We don't have a pyramid though, we have a prism, meaning that the other faces are either going to be a rectangular or square shape. So we're just going to go ahead and draw the other shape, flat shape needed to make a pentagonal prism, which would be rectangles. We would have 1, 2, 1, 2, 3, 4, 5 rectangles. And then we would have a base and a top that are both these pentagon shapes. Okay, for a total of 7 faces. And again, we're not going to really draw the net. Okay, next we're going to look to name the solid that is created by this net. We're also going to really challenge ourselves to count the number of faces, edges, and vertices, which is pretty difficult when you're looking at a net. At least I think that the edges and vertices are difficult to see without imagining that figure all folded up. So let's start with the shape of our base. Now, oh, this is a little bit tricky. I see that I have 4 shapes in my net, and that all of them are triangles. That means that one of them needs to be the base, and that one of them, the shape of our base, needs to be a triangle. Okay. I also see that the 3 other faces are triangular, and that if we were able to fold this up, that each one of these 3 triangles would fold up and meet at one vertex, meaning that this is a pyramid, a triangular pyramid. Okay, next, I'm going to erase those little marks I made here. We're going to work on trying to name, or not name, identify how many faces, count how many faces this figure is made up of. I think this is pretty simple. We have our base and then 3 triangles for a total of 4 faces. Now here's where it gets pretty hard. We are going to count the number of edges, but to do this, we kind of have to think about this net being folded up into a solid. It's tricky to mess this up, so I'm going to use my blue pen right now. Now I know I can count my base, each one of those sides, as a edge, okay, because I see that's where 2 faces meet. So far in our base we have 3. Now we can't count this and this, because when we fold these up, these 2 lines are actually going to meet to form one edge. And this line, these are going to fold up and meet, and they are going to form one edge. And this line are going to fold up and meet, and they're going to form one more edge. So we have a total of 1, 2, 3, and 3 for a total of 6 edges. Okay. Don't want this to get super duper messy, so I'm going to try and erase it pretty quick. Okay, again, now I said we were going to challenge ourselves. I think this is difficult to count the number of vertices. Remember, vertices are where 3 or more edges meet. Okay, now this might be a little bit difficult. We're going to start with our base. Okay, I see we have an edge here and an edge here. And then these two lines are going to come together and form an edge that is also going to meet at this point. So that is a vertice. That means that this can also be counted, and so can this. Okay? So you might be thinking, 3, we got them all. But think again, if we were to fold this up into our triangular pyramid and make it into a solid, each one of these points of these triangles would come together to form one vertex. So we have to add that 1 onto the 3 we already have, and we will have a total of 4 vertices. Okay, this is going to be the last figure that we practice this with today. Again, we're going to be looking at identifying the solid that this net creates when it's all folded up. We're also going to be counting the number of faces, edges, and vertices. Okay, first thing, we're going to work on identifying what solid this makes. I see right now that the top and the base are both squares, and that each one of the other 4 faces are rectangles, meaning that this is a prism, and this is a rectangular prism. I'm going to run out of room to write that, but I'm going to try my best. And I kind of overlapped. I think that's okay, though. Okay? Okay. Next, I think it's going to be pretty quick for us to count the number of faces. We have our top and our bottom, or a base and our top. 2, 3, 4, 5, 6. 6 faces. Okay. I'm going to be erasing this so we try and stay a little bit organized here. Next, we're going to count the number of edges. Now, this is tough when you do this with nets because you really have to imagine folding this up and not double counting lines that aren't connected already. So what I mean by that is when we think about this being folded up, this line, this line, this line, and this line, those are all edges. So we know we have 4. I'm going to go ahead and do my base and my top first. This line, this line, this line, and this line. Those are all going to meet with other rectangular faces and make 4 edges. Remember, edges are where those faces meet and form a line. Okay, now I'm going to count the ones that are easy first. So I have 1, 2, 3 here. Now here is where the biggest mistake happens. A lot of times kids will count and they'll say, there's a line here and a line here. And then I have 1, 2, 3, 4, 5, and then 4 plus 4. I have 13 then. No, because if we were able to fold this all up and this face would kind of roll over and roll over, here and here would connect and form one edge. So instead of counting 5, we need to instead count this and this together as 1. And then 2, 3, 4. So we have 4 on our base, 4 on our top, and 4 in the middle with those rectangular faces for a total of 12 edges. Okay, I'm going to kind of erase all this again. Let's go ahead and use yellow now. Now we're going to identify our vertices. And this is also kind of tricky because you don't want to double count any or miss any. But think about if this were all folded up, especially thinking about your base and your top. Okay, we're not going to have any vertices made in this middle part at all because there are not more than 3 edges coming together to form that point. But I do note that when this is all folded together, I'm going to have a vertice here and 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 here for a total of 8 vertices.